Wasabi, you guys. Welcome to Integration Bee Training for Advance. We're still doing King's Rule, and I believe this is the fourth section. Yeah. And in this section, we will be doing some crazier advanced King's Rule techniques. In this case, we'll be dealing with exponentials and other miscellaneous functions. Okay. So now we are in the most difficult, the sneaky tricks of King's Rule. So let's go ahead and get started with the first integral. Alright, our first King's Rule manipulation integral. So what do we do here? Of course we see 1 minus x out of nowhere. So there's suspicion that we're going to do King's Rule. Okay, so of course when we do u equals 1 minus x, we get 1 minus x here, but these don't interchange. These don't change the denominator because of, addition. It's commutative. So, okay, so the denominator doesn't change. So let's go ahead and add these two integrals together, which gives us, let's say, a half, so that we don't have to do the 2i. And this plus this is going to give us 1. Alright, now I believe it's a lot easier to solve. I know that 1 minus x might throw you off a little bit, but don't let that distract you. Do not let that distract you. Just go with the flow. What do we do when we see a negative x like this? In algebraic manipulation, we just multiply e to the x top and bottom, e to the x here, e to the 2x here, and then this is just e. E is just a constant, so don't let that distract you. Right, so here, this is just let u equal tangent, I don't know why, e to the x. Right, so now we have, so you let e to the power of 0 is 1, e to the power of 1 is e, u squared plus e, which is equal to 1 over 2 root e inverse tangent of u over root e from 1 to e. And so our answer is, let's see, the inverse tangent of square root of e minus the inverse tangent of 1 over root e. Dang, this would have been nice if this was plus, then it would just be pi over 2. And it would have been like pi over 4 root e. But because this is minus, we're just going to leave it like this. You could simplify it. Wolfram Alpha does this thing where like inverse tangent of 1 over e. It's good, like pi over 2 minus inverse tangent. So Wolfram Alpha would answer it like, I think this is how Wolfram Alpha would have answered it, but I would just leave it like this, just for the sake of time. Okay? 2x squared minus 2x plus 1, that is interesting. Let's see, there's something suspicious. We have x, 1 minus x, so seeing this, and seeing that this is x squared plus x minus 1 squared is very suspicious. Or maybe 1 minus x squared. I don't know. But very suspicious. Probably, definitely using King's Rule. Okay. So if we do King's Rule, of course, notice that if we do u 1 minus x, we get 1 minus x squared, e to the x plus e to the 1 minus x doesn't change, and this doesn't change because, like I said, this is technically 1 minus x squared plus x squared. Okay, and of course, I see where this is going. If we add these two, right, we're factoring out this portion here. So we're going to go ahead, add them together. I'm going to put a half. And notice that we have x squared plus 1 minus x squared. And I'm just factoring this portion out of the way. And this denominator, like we saw, equals to this. And then of course this portion cancels out. So what we actually have is a half of, from 0 to 1, e to the x plus e to the 1 minus x dx. This is equal to a half of e to the x minus e to the 1 minus x. Be very careful not to go too fast. And then 0, 1. Okay, so let's go ahead and start plugging things in. We have e, plug in 1, this is e minus 1. And then minus, plug in 0, we get 1 minus e. Wow, so I guess this is equal to e minus 1. Of course. You already know what to do, right? You see the suspicions, 2 minus x. There's so many x's in 2 minus x. King's rule, right? Okay. So let's go ahead and perform King's rule. We know that this is going to equal, if we do u equal 2 minus x, the places of 2 minus x and x interchange. They switch places. And then these two, the denominator doesn't really change. All right, we're starting to develop a sense of King's rule now. Okay. And then of course we add these two integrals together. And then we get, let's see, 1 plus 1 is 2. Let's see, plus ln of this plus ln of this. This becomes ln of 1 by logarithm rule, and then equals to 0. Okay? And then we're just left with this denominator here. So what we technically have is from 0 to 2, we have x squared plus 2 minus x squared. We could actually go ahead and simplify this. Now that we have an elementary integral, this is x squared plus x squared minus 4x plus 4. So I'm going to factor out the 2. X squared minus 2x plus 2. Oh, beautiful. Would you look at that? Complete the square. And we just get x minus 1 squared plus 1. Right? Which is equal to, if you let u equal x minus 1, this is just u squared plus 1 du. Negative 1, 1. Oh, how convenient. Symmetry. How convenient. So this is just equal to pi over 4 then. The whole answer, the whole integral, is just equal to pi over 4. Oh god. Okay, so I mean, I do see that we have x, 2 minus x, right? But of course we have 0 to 2. But what's kind of throwing me off here? Let's see, this. This is inverse tangent of 2 minus x over x. It's just in a different form. So don't let that stun you. Okay, cool. We know what to do then. So then this integral is technically equal from 0 to 2. This is equal to x over 2 minus x. And then the denominator is the same thing. Alright, add these two integrals together. We get a half from 0 to 2. We know our trig identity. If we add this plus this, we're at the positive bound. So this is going to equal to pi over 2 when we add them together. And the denominator stays the same. Okay. So this is pi over 4, 0, 2. Well, this is cool. What's amazing about this is that 2x minus x squared, you just complete the square. That's all you're doing. So minus 1 plus 1, this will give us 1 of x minus 1 squared. So what we have is 1 minus x minus 1 squared. Okay. And now, from 0 to 2, we can just go like this. If we do u substitution, du 1 minus u squared, negative 1 to 1, symmetry, times 2. This gives us pi over 2 of, pi over 2 of inverse sine of u, 0 to 1. This gives us pi squared over 4 as our answer. And we're done. Look how fast that was, right? If you keep this up, get more comfortable with King's rule, solving very difficult integrals like this, you would be a very dangerous competitor in your integration bee. All right, let's continue. Now we have reached a territory, a barrier, where this is some very, very difficult, sneaky stuff with King's rule. Okay? So, we are given a function, 4 to the power of x over 2 plus 4 to the power of x. And we're integrating the a composite of itself. Okay? Now, I'm not gonna write out f of x, because that's you know. But we're going to do some manipulation here. So, just to kind of ease our stuff, let's see. What I'm going to do is I'm going to divide 2 to the power of x, just 2 to the power of x. Okay, I'm just going to divide 2 to the power of x. That's all I'm going to do. So what this would equal is 2 to the power of x, 2 to the power of 1 minus x, 2 to the power of x. Ah, okay. Now there's something. Or is there? Well, I mean, it's not 0 to 1. It's not... Well, it doesn't have to be 0 to 1. It does not have to be 0 to 1. Do you remember the King's formula, right? A plus b minus x. Ah, notice that 3/4 plus 1/4 equals to 1. So what this means is that when we let u equal 1 minus x, then what? 1 minus 3/4, 1/4, 1 minus 1/4, 3/4. What this means is that the bounds will still not change. And that's what King's rule is for. So, of course, we could still apply King's rule, okay? Because the bounds, they add up to 1, which is what we need for 1 minus x, okay? Cool. Here's another thing, though. I'm not done. Here's another thing. I noticed something. What if we just... Well, we're not doing King's rule with the function, but notice that f of 1 minus x makes no difference with the denominator. Okay, if you do 1 minus x here, it's going to be x. Okay. So now what? Well, let's keep in mind that these two functions equal to 1. Ooh. Keep this in mind. I know it's a lot to take in, but just keep this in mind. Again, this integral is a very, very difficult integral. It's a very difficult case of King's rule. Okay, so now let's get back to the integral. So if we let u equal 1 minus x, all this does is just gives us the same bounds. Instead, it changes the integral as 1 minus x. Okay. Now, remember that f of 1 minus x is equal to 1 minus f of x. So what we have is that f of 1 minus x is equal to 1 minus f of x. So this is equal 1/4, 3/4 of f of 1 minus f of x. Okay. Now what? Well, this is where the tricky stuff begins. So now here we have this formula, right? F of 1 minus x is equal to 1 minus f of x. Then f of 1 minus f of x is equal to 1 minus f of x. Whew. Mind-blowing, right? Yes, this is now 1 minus f of x dx. And you probably already know this. Oh, like you know where this is going, right? We have our original integral equal to I, right? Equal to I. Okay. And then all of a sudden we get I is equal to this integral from 1/4 to 3/4 of 1 dx minus I. And so now we have 2y equal to this integral, which is 3/4 minus 1/4, that's 1/2. And so now our integral is equal to 1/4. Okay? That was a lot to see. It's a very difficult problem. It is a very difficult integral to see. I don't blame you. But it was a lot of manipulation. But this was a beautiful example of King's rule manipulation. Okay, last integral for you guys that I've made. So this integral, what do we do? What do we do here? So this looks horrible. It looks terrifying. Let me put this in terms of a function. Let's see. Well, we have this constant out of the way, so I guess we could just do 2 over pi, and then pi over 2. Okay. Now, what I'm doing is I'm letting f of x equal to 2 over pi inverse sine the square root of x. Pretty much I'm following the inside of this, right? Our integral that we have is literally this. Okay? Alright. So, you think we could apply the same trick that we did in the previous integral? Most likely, probably. Well, let's try it. So, how do we do this? How does this work? Well, let me show you another trig identity. A very advanced trig identity. You don't have to memorize this, but it's good to keep at the back of your mind. I only teach this like very serious competitive or G-main level stuff. So whenever you have inverse sine of 1 minus x, okay, this is equal to inverse cosine of x. And then same thing kind of goes for the other side as well. Now this is equal to inverse sine square root of x. Okay? Now, of course, this only works for x between 0 and 1. Right? So, of course, this is only true for x between 0 and 1. Okay? Alright, so now that we have that formula to keep in mind, let's go ahead. Let's see what happens if I do f of y minus x. Then we get 2 over pi. And like I said, inverse sine of square root of 1 minus x is equal to 2 over pi inverse cosine of x. We have another trig identity, which you probably already know. If you've seen my if you watched the intermediate training series, but if you don't remember, it's okay. I stated before that this was an important identity to remember, and it's that this is equal to pi over 2 for x between 0 and 1. Okay? So now that we have that, notice that when we add f of x plus f of 1 minus x, then we get 2 pi. We can factor out 2 over pi, and we get inverse sine of square root of x plus inverse cosine of square root of x. Would you look at that? This is equal to pi over 2 times 2 over pi. This is equal to 1. Okay. Aha! Alright, now we know what to do. So, of course, this is technically pi over 2 from 0 to 1 of f of x. Okay? And so now, we let u equal 1 minus x, which, of course, it's just f of 1 minus x. And we know that from here, f of 1 minus x is equal to 1 minus f of x. So we have pi over 2 f of 1 minus f of x. And then, of course, if you remember, we can apply the same thing with f of x plus f of 1 minus f of x, which also does indeed equal to 1. Right? So, what this means is that this whole integral here is pi over 2 from 0 to 1 is equal to 1 minus f of x dx. Cool. And now what we have here is we technically have this is equal to I, right? So now we have I equal to pi over 2 1 dx minus I. So now what we have here is 2y is equal to pi over 2. So what does this mean? This means that this whole integral here is equal to pi over 4. So I guess I could just write it all out. This integral from 0 to 1 of the inverse sine of the square root of 2 over pi, the inverse sine of the square root of x dx. This is equal to pi over 4. Okay? And that is it. And we have finished our King's Rule chapter. Again, this section is very difficult to grasp. You're going to have to repeat this over and over until you become very comfortable with King's Rule manipulation. Okay? So I highly recommend that you just rewatch the videos and try the integrals yourself. If not, look at the solutions and then do it again until you gain a mental sense of this. Okay? So, yeah, that's about it. The next part, we will be going into Queen's Rule, so stay tuned for that. Other than that, stay safe. Thank you so much for watching, and I'll see you guys in the next video.